Okay. So we were discussing on the palm leaf members. Okay. So we'll continue that. And what we saw yesterday is we discussed about this address space. Okay. So we discussed like in common area how these address spaces are allocated. Okay, so the main this is an overall address space format. Okay, so if you see any of the address space internally, this will be the structure of the address space. So during IPL, okay, your system will build this address space. Okay, so how it will build the address space is it will take help of your IEA SYS member, and using IEA SYS member parameters, formally parameters, it will uh, try to build this address space. Okay, so using IEA SYS, it will include your PLPA, FLPA, and MLPA. Then CSA, it will allocate the region for CSA, it will allocate the region for SQA. Okay, only nucleus it will take from your load XX member, not from your IEA SYS member. Okay, so we also discussed what is the 16 MB and 2 GB line. Okay, so now we will continue from here again. Okay, so we were into IEA SYS member. So we'll go back into IEA SYS member. So this was our IEA SYS 01 and we were in LPA. Okay, so LPA, when you give LPA MLPA 00, okay, so when you give MLPA 00, the member it is taking is IEA LPA 00.
Mm, okay.
Okay, IEA LPA 00.
Okay.
Okay, so now we'll try to understand more about your LPA, that is your LPA LST 00. Okay, so now where you will find LPA LST 001, in which palm leaf member you will be finding it?
The same palm lip. This one.
Same
Oh,
palm leaf member.
yeah.
Okay, now we'll try to go into LPA LST 00. Okay, so what I try to explain you is LPA LST member. It contains your uh, modules for your system when your ZOS upgrade will happen, right? So what and all features the ZOS, new ZOS will be having, those all feature modules will be given under your LPA LST member. Okay, and most of the modules will start with your sys1. Okay,
Okay.
so if there are any in between user defined data sets and all, so that you should not consider it as a standard way of configuring the system. Okay, so whenever you say LPA LST, LPA LST member, okay, most of the data sets will start with your SYS1.
Okay.
Okay, so now if your system is unable to find LPA LST01, then by default it will take all the modules from sys1.lpa lib. Okay,
Okay.
sys1.lpa lib. Okay, so
Okay.
now we will try to understand more, like take some of the details on LPA. Okay, so how do you mention it is like LPA equal to, you are giving the parameters like this. Okay, so if you are giving two parameters like a comma bb, the second will be taken as above the 16 line, 16 MB line.
Okay.
Okay, if you consider this address space, then it is covering this LPA, this PLPA, FLPA, and MLPA, as well as your extended PLPA, FLPA, and MLPA. So it means that your programs will be running above the line as well as below the line.
Okay.
Okay, so now why this LPA is used is, okay, so to add the installation read only return programs, okay, to pageable link pack area. Okay, so a re-entrant, in the sense you might be knowing the meaning of re-entrant programs. Okay, so if you want to add any re-entrant programs to the link pack area, those all programs will be there under your LPA LST. Okay, second thing you have to remember is placing programs in the PLPA allows them to be shared among all the users of the system. So whatever modules you are placing in your sys1.lpa lib, or in this LPA LST concatenation, that will be shared among all the users in the system. So why it will be shared among all the users in the system? Because it is the common area of your address space.
Okay.
Okay, as it is a common area of the address space, it will be used by all the users of the system.
Okay.
Okay, so the next point you have to remember is these data sets form your operating system. That is why we keep them in a common area. Okay, so the modules defined in LPA LST must meet the same requirements as the modules defined in sys1.lpa lib. Okay, the modules defined in LPA LST, okay, must meet the same requirements as the modules defined in sys1.lpa lib. It means that the attributes of the module, okay, that should be same when compared to your sys1.lpa lib. Okay, so what happens is during your NIP phase, okay, the system opens the concatenation of each data set specified in your LPA LST member. Okay, so LPA LST concatenation, okay, can have maximum up to 255 data sets.
Okay.
In LPA LST, you can specify maximum
Two.
255 data sets. Okay,
Okay.
so these are the like important points which you have to remember. That is why I'm explaining you. Okay, so the system builds your PLPA, FLPA, and your LPA, LST, FLPA, MLPA, and PLPA, which I have mentioned here in this. So these three, PLPA, FLPA, and MLPA, using your LPA, LST concatenation. Okay,
Okay.
so if your LPA LST cannot be opened, then system will give a message. So I have explained you morning what is that message. So if the system, while in the NIP phase, if the system is unable to find the LPA LST PalmLib member, okay, then what is the information message it will give is IES 712Y. Okay, this you have to remember, IES 712I. Okay, so one more point is if LPA LST cannot be opened, okay, or there are no members mentioned in the LPA LST concatenation, then your default members will be picked from your sys1.lpa lib.
Okay.
Okay, so if you go here and now your next parameter is MLPA equal to 0, 0. So the member what it will be selecting is IEA LPA 0, 0. Yeah,
Okay.
IEA LPA 0, 0, and this will be there inside the same palm leaf.
Okay.
So here nothing is there. Okay, it is a dummy. Okay, this palm leaf member has been customized or you for your order. Okay, if there are any statements below, they are required in an order. So here what they will do is they will use include parameter and they will include the required members. So let's see if we have one more IEA LPA 0, 0 member. See, IEA LPA, okay, IEA LPA DI we have. Okay, one more is IEA LPA DI. See, they will include the remaining members in this format. Okay, so
Okay.
include library. Okay, so this is the data set they are including. Then from this data set they are including these modules.
Mm.
So again these are your load modules of the suppose DFS. These are all like load modules of your operating system.
Okay.
Okay, so we'll go back to so we saw a clock member. Then we saw your LPA, LSTM, LPA. Now the next important is your master JCL. Okay,
Mm.
this one, master JCL. So what is this master JCL? MSTRJCL equal to 0, 0. What it will do is it will, okay, MST MSTR JCL. Okay, so this is one of the your PalmLib member under your IEA SYS.
Okay.
Okay, so now what happened is your system. Okay, when in for your system during IPL, you have given IODF data set as input. you gave your load XX as a input parameter. Okay, then using that load XX, your system tried to read your master catalog. Okay, from your master catalog, your system was able to read all the required system data sets. Okay, then you gave your palm lip concatenation to the operating system. Okay, using your load XX member. Okay, then you gave IEA SYS and IEA SYM. Okay, you also gave an input of your nucleus, what nucleus the system should use. Okay, so when you have given IEA SYS as input, okay, inside the load XX, your system started reading all the required palmlib members for the system to start its configuration. Okay, so here your system, what it will do is it got it it got the information of your nucleus. Okay, now your system will start building the required address spaces for the system to operate properly. Okay, so for that the system requires your nucleus. So we gave the nucleus details in your load xx member. Okay, second, yeah, what you did is you have given an address range using your SQA value. Okay, so using SQA, you have given the required queue area for the to manage the queue. Then you have given the CSA value, common storage area value. Okay,
Okay.
then you have given the system your uh, LPA LST. Okay, which
Okay.
is your most important thing, LPA LST. So in LPA LST, you have given it FLPA, okay, MLPA and PLPA. Okay,
Okay.
these three parameters. So now your IPL, when you are doing an IPL, now you have given the operating system the complete details which your operating system will use to get its configuration started. Okay, up to here, your um, operating system, what it did is it tried to build the address space. Okay, now once it has built the address space, your operating system has to start this addresses. Okay, it has to start the address. You call it as a address or you call it as a task. Okay, now the next thing what your operating system will do is it has to manually start all the address spaces.
Okay.
Okay, so for that your operating system will use your master JCL, MSTR JCL and your just to pump.
Okay.
Okay,
Okay.
so these are the two important things, two inputs which the system will again get from your IEA SYS member. Okay, for that we are now seeing what is your master JCL. Okay,
Okay.
so now we went into your master JCL here. Okay, so what your master JCL will do is it will be having all the remaining uh, address spaces or the started task, okay, that the system has to start it. Okay, so this is master JCL is the first address space. Okay, master JCL is the first address space which will be coming up when you do the IPL.
Mm.
Okay, so that is why this master JCL will be having your address ID as 01. Okay, so if you go here into your STSF, See, here you can find master. Okay. So
Okay.
this is your master address space, which will be brought up by your master GCL. If you do an function F11, I think so. See, your address ID will be 1.
Oh,
Okay. So this is your first address space, which will come up. So this address space will bring all the remaining, whatever address space you are seeing here. Okay. All this will be brought up after your master.
okay.
Okay, so you can see the address ID is here 2, 3, 4, 5, 6, 7, 8. Okay, so this is the sequence in which all your address spaces are coming up.
Okay.
Okay, so if someone asks you which is my first address space, which will be coming up is your
Mr. JC.
master address space, which will be brought by your master JCL.
Okay.
Okay, now next thing what you have to remember here is when your master address space is coming up. Okay, will be not having any initiators because your system is still in the NIP phase. Okay,
Okay.
nucleus initialization phase. You will be not have you know the importance of initiators, right?
Yeah,
So why we use initiators?
it will accept the jobs from the just to, and it will manage the execution of schedule and execution of job JCL.
Right. So what initiators will do is it will handle the input.
Yeah.
Okay, it will handle your workload. So how initiators will handle the workload is using your class parameter.
Yeah. Yes.
Okay, so your admin will assign a class parameter. So every initiator will be internally associated with a class parameter. So using this class parameter, your operating system will assign the address spaces to the jobs which have been submitted. That is done by your just2. Okay, so now here, why we came into initiator topic is when your first address space is submitted. Okay, or you can say when your first address space, master address space is now up. Okay, so it has an address ID of 01. Okay, so when this master address space is executing, we don't have any initiators. So
Oh,
how this master address space will execute? Okay, so for that we are using a concept called as internal reader. Okay, so internal reader is a program. Okay, whenever you code internal reader, okay, you don't require any initiators for that particular program to run.
okay.
Okay, that is why in your master JCL, which is your first JCL, the operating system will be submitting during the NIP phase. We don't will be not having any initiators. That is why we make use of your internal reader. So using internal reader, this job will be submitted and it will start executing. Okay, now I said you that master JCL will be always having an address space of 1. Okay, so how this master JCL got an address space of 1, address ID of 1? So it is getting an address ID of 1 using this program
Okay.
IEEE MB860. Okay,
Okay.
IEEE MB860 is a program which creates an address ID of 1. This is an interview question they will ask you. Master, which is the started task which will be having the address ID of 1. That is your master JCL.
Okay.
Okay, master JCL will start submitting all the other started tasks.
Okay.
Okay, so I don't have initiators in the NIP phase. How the master JCL will be submitted? So
Indian.
master JCL is internally using a program called as internal reader. Using internal reader, your master JCL will start executing.
Okay.
Okay. So what does master JCL do? Okay. What does master JCL do? Master JCL will be having all your proclip concatenations. Okay. Master
Okay.
JCL will be having all your proclip concatenations mentioned in this DD, IEF, PDSI. Okay.
Okay.
IEF, PDSI will be having a proclip concatenation. So this proclip concatenation will be having all the started tasks. Okay, I will show you now. If you go here again, we'll go back now, not here. Okay, start again. You do TSOSD. So, okay, so here you went into DA panel. Okay, you did function F11 here. Now see, your master address space was having an address ID of 1. Okay,
Mm.
now as I said you, your master JCL will be having a proper concatenation, and your master JCL will bring all the remaining this one the remaining address spaces. It will submit the remaining address spaces. So where those address spaces will be uh, saved is, it will be saved in your proclip, and some of the address spaces which you have mentioned here. Okay, so in that proclip we'll be having some of the address spaces, and some of the address spaces will be there under your just to proclip concatenation. Okay, so whatever you are seeing here, okay, these are your started task or address spaces or procs, you can call procedures. Okay, so how this will be started is, internally it will use a command called as yes space task name. Okay, so for this yes space task name to get submitted, it will be saved under a proclip. Okay, so if you go back here into your master JCL, okay, so now you can see this is your proclip concatenation. This proclip concatenation will be having all the required procedures which your master JCL will be submitting. Okay, so first address space is your master JCL. Okay, second address space is your just to.
Step. Okay.
Okay, just to. So now we got your master JCL. How we will get the just to is, you have to go inside this. Okay, in this proclip concatenation, if you enter into this, okay, find forever just to. Okay, see. So inside this proclip, we will be having just to. So how the just to will get submitted is yes space just
Just.
to. Okay, so yes space just to. So now if you go inside your just to, here your just to will be again having its own proclip concatenation.
Okay.
Okay, so just to will be now submitting the required the remaining started task. Okay, it will be submitting the remaining started task. So for your system to come up properly, first thing is your master JCL. Second thing is your just to.
Okay.
Okay, so sometimes in some of the operating system, you'll be seeing that a RACF is a subsystem which will be coming up before your just to.
Okay.
Okay, so where RACF will get submitted is under your master JC
Okay.
concatenation. Master JSL, Proclip concatenation, you will be finding your rack of.
Okay.
Okay. So now this just 2 will be having its own Proclip concatenation from where it will submit all the remaining started tasks. Okay. But the functionality of your just 2 will be given under your this DD. HAS, HASP, PARM. Okay,
Okay.
like how your just to should start. Okay, for your just to start, what and all is required. Okay, like for your operating system to start, we gave the your load XX member and you give your IODF data set, right?
Yeah.
Similarly, for your just to subsystem to start, what and all is required will be given under your just to palm lip concatenation. Okay,
Okay.
so we gave a command called as initially we gave a command called as display palm lip, right?
Yeah.
Display palm lip. So this gave you the palm lip concatenation under your load XX member. Okay,
Yeah.
so for your just to you have $D prop lip. Okay, it doesn't have a palm lip concatenation, it has a proc lip. So all this proc lip will be displayed when you give this $D proc lip.
Okay.
Okay, so why we are using this proc lip concatenation is whatever address spaces your just2 will be submitting.
Okay.
Those all address spaces will be there in any one of this
Palm. Yeah.
proc lip concatenation. Proc lip concatenation. Okay, and how your just2 is um, operating will be given under your hash farm dd, that is here. Okay, so now we are entering into your just two. Okay, so now we will go into and member is your this one where
Sim.
it is just to palm.
Yes. Wow.
Okay, so now we will enter into your just two. So here we have your just to palm. Okay, so once you come inside your Gesto form here, you can find the functionality of your Gesto form. Like your Gesto, when you enter into the Gesto, Gesto has its own checkpoint data set. Okay, so Gesto is one of a subsystem. Okay, important subsystem. So Gesto has its own data sets, checkpoint data set. Okay, the way you will do cold, warm IPL, right? Similarly, you can do warm and cold start for the just two.
Oh,
Okay, so whenever yeah, so when we take just two, no, that time we will see more detail. So when you do a cold restart for your just two, okay, that time these checkpoint data set will be cleared. Whatever is there inside this checkpoint data set,
it'll be clear.
okay, everything will be wiped off
Okay.
when you do a
Cold.
cold start of the just two.
Okay.
Okay, so they will ask you what are the checkpoint data set under just two. Okay, so it is HASP ending with this one dot HASP. So there will be two data sets.
Okay.
One will be the primary, second one is the other one will be the backup. Okay, so
Okay.
when you do a cold start of your just two, it will clear up these data sets.
Okay.
So see this just two Palm, just to Palm a Palmlib member will give you the complete functionality of your just to. Okay, so it is showing you the just to check one data set. It is showing you on which volume serial these data sets are saved. Okay, similarly, it gives you the detail of what is the command prefix you used for your just to. See here in your there is a member called as dd called as condef. Okay, in condef you can see con character equal to dollar. Okay,
Mm.
so your whatever your just to commands will be executing, that will be starting with a dollar sign.
Okay.
So if you change it here to d, okay, all your just to commands you can execute using d.
Oh, okay.
Okay, so like now if I'm giving this one dollar d proclaim,
Okay.
so if you change it to d,
D,
then we're giving
D, D.
dd proclaim.
Okay.
Similarly, you will be having your inits, the functionality of initiators.
Okay.
See here, okay, init def is there, no? So your init def will be defining all your initiators. Now suppose init one, okay, this is your first initiator. So this initiator is assigned a class called as class A. Okay, so if you say start, it will start automatically. No need to manually start the initiator. So initiator 2 is having two class A and class B.
Okay.
Okay, so see here, initiator 4 is having class A, B, C, and D. So if you submit any job with a class parameter of D, it will pick initiator 4 and it will start
Mm.
executing.
Okay.
Okay, so like this, the class you in your job card, you will give a class. You will give class equal to D. Then it will pick initiator 4.
Okay.
So internal reader definition will be there here. So this is one of the important thing. NGE def. Yeah. So what this does is NGE definition. Okay. So NGE is an external uh, link to your uh, LPAR. Suppose now you are transferring one data set from one LPAR to another LPAR using your NDM. Okay, network
Okay.
data movement or FTP. If you transfer a data set, okay,
Yeah.
once you open your system, the first message in a red color will be getting it as a NJE. Okay, so
Okay.
whenever it comes inside your operating system, if it is defined here, then only your Gesto will take it.
Okay.
Okay, so this detail we will be seeing about NG under your Gesto
Okay.
when we enter into Gesto. So this is your just to understand like what and all will be coded under your Gesto.
Okay.
So your school definition will be given under Gesto. School def. What is the maximum size for the school?
Okay.
So these all parameters we will see once we start with the Gesto. Okay. So this completes all the important load on this one. Your Palm Lib members. So I think okay. So if any other Palm Lib members, we'll take it again in the next class. Okay. So you have any questions?
Mhm.
Okay. So we'll stop it here
Okay.
and I'll close the sharing. Okay.
Oh, okay.
I can stop recording.
Yeah. Let me stop.
Tomorrow again, like tomorrow evening, we'll meet around